Okay, another video here to cover the notes on surface area of pyramids now. So hopefully you've already watched and completed the worksheet on surface area for prisms, but this one obviously we're going to talk about pyramids. So you need to know what exactly a pyramid is and what shapes it's composed of, and then how do you find the surface area of a pyramid. It's our other essential question. All right, so starting off here, so pyramid. Pyramid is a 3D figure with a polygon base, which again, a polygon is any figure or any shape with more than two sides. So basically a two-dimensional, not three-dimensional, two-dimensional shape. And then the lateral faces, as we can see down below in the diagram there, they're going to be triangles, so triangular lateral faces that come together at a single point. Okay, and that's kind of the other thing. This is sometimes referred to as the peak or the vertex. Of the triangle, but that's the central point that all of the lateral faces are coming to. So unlike with prisms that have the similar bases on either side, here we just have a single base and then all just meeting at a single point at the other side of the three-dimensional figure here. Another important term here for us is what the slant height is. And so you can see slant height is labeled here on this pyramid. And so it's the height of each again, they are triangular lateral faces. Okay, so it's not the height of the pyramid, right? Because the height of the pyramid would actually drop down from the center and go straight down to the base. And so it's not the overall height of the pyramid, and that's why we give it a different name and call it slant height, because the outside of the pyramid is kind of the slanted portion of it, and so it's the height of those triangles out there. But that's going to be important for finding the surface area for when we need to find the area of those triangles. Okay, so in this you can see here's the three-dimensional version, here's the two-dimensional layout of it. So basically if we were just to fold down each of the triangular faces, you in this one have a square base, and so that's going to fill in this answer down here, which causes it to have, in this case, it's going to have 4 lateral faces then. So in a pyramid, the number of lateral faces is determined by the shape or the two-dimensional polygon that is the base. So if you have a triangular base, then it's going to have 3 lateral faces. If your base was a pentagon, which has 5 sides, then you would have 5 lateral faces and 5 triangles, making that up. For the purpose of what we're going to be doing, we're going to focus on some triangular-based ones and also some ones that have quadrilateral bases, so either squares or rectangles. And that's really as far as in-depth as we're going to go at this point with things. Okay, so then define surface area. So the surface area is still, even for a pyramid, is going to be the sum, or the if we added up all of the areas of all of the sides. So the outside total area. And so for a pyramid, that means that we're going to have the area of the base plus the area of all the lateral faces. So down here in our little formula, area of base plus area of lateral faces. And again, the number of lateral faces that we're going to have is going to be determined by the type of base that our pyramid has. Okay, so here's an example of that being done. So here we have another pyramid that has a square base to it, and so again here's the three-dimensional representation. Here's what it would look like in 2 dimensions. And so we have an area of our base, which is a square that's a 5 by 5, so 5 times 5 gives us 25 for the base of that square. Then we have our lateral faces, which are triangles, and so remember for triangles we have 1/2 times 5 times 8 here. The way that we usually write it, remember for finding area of a triangle, is base times height divided by 2. But remember, multiplying by 1/2 achieves the same thing as multiplying, or sorry, excuse me, dividing by 2. So that's why these are still representing the same. So if the base of the triangle is 5, the height of the triangle is 8, it's 5 times 8, and then divide by 2 or multiply by 1/2, and that gives us 20 here. And so then for the total surface area, it'd be the 25 from the base plus 20 plus 20 plus 20 plus 20 for each of the lateral faces. Or we could shorthand that to 25 plus 4 times 20, right? Because we have 4 of the triangles. So when we start actually making our calculations in our examples, instead of writing it out 20 plus 20 plus 20 plus 20, if we know how many we have of those similar triangles, then we can just multiply by the number that we have. So in total here, that would mean that we have 25 plus 80, which would be equal to 105, in this case, inches squared again. So just like with the prisms, again, we're finding an area here, and so we want to use our square units for when we're labeling our numbers, and so it'd be 105 inches squared for the surface area of this pyramid. Okay, column question over here. Can the base of a pyramid be a circle? Explain why or why not. So if we think about it, if we had a base that was a circle, and then if I tried to have a central point for those all to come to, so I could have a triangle across here like this, but once again, we need it to be a polygon, right? So we need a multi-sided figure here. So the answer here is no, that I can't have a pyramid with a circular base because I can't make those triangular lateral faces from each of the sides. Okay, so no, because the lateral faces would not be triangular. Really, we don't really have lateral faces when it comes to a shape like that. Now, that is a shape, right? And so number 2 is a follow-up question to that. So what do we call a shape with a circular base and lateral faces that meet at a single point? Again, kind of hard to call them lateral faces, but assuming we make this shape here, and so hopefully you've recognized that shape and identified that because that is a cone. Okay, so you can find the surface area of a cone. We just can't use the same type of idea as a pyramid. So a cone is kind of like a special type of pyramid in a way. We will cover that at a later point. Okay, to the next page. So finding the surface area of each of these pyramids. A couple examples here to go over. Okay, so in this one, once again, we have a square base. And then we have, because of a square base, we're going to have 4 lateral faces, those triangular lateral faces. So if I start with the area of the square first, well, it's got a length and width of 6. So just length times width for that. And so 6 times 6 gives us 36 feet squared there. Area of our triangle then for lateral face, well, it's going to have a base of 6 feet as well, and the lateral face slant height is 9 feet, and so that's going to be the height of our triangle there. So it'll be 6 times 9 and then divide by 2, which gives us 54 divided by 2, which would be 27 feet squared. Okay. So putting it all together then for surface area, we've got our single base, so 36 we got from that, plus 27 feet squared is each of our lateral face triangles, and we said that we had 4 of those, so 4 times 27, okay, which gives us 36 plus 108 then, And so all in total, 144 feet was the measurement, square units for area, and so the surface area of this pyramid, 144 feet square. Okay, for number 2, this time, if you notice, what we have is we have a pyramid that has a triangular base. And so we've got the side of the base here being 9 yards. We're going to assume that it's the same all the way around, that it's an equilateral triangle on the bottom here. So this is also going to be 9 yards on this side. You'll notice the 7.8 yards, that's giving us the height of the base of the triangle. So the triangular base, its height there. And then this, 10 yards, is our slant height for our lateral faces. So this time, our base is a triangle, so we have to use the same formula that we did for our lateral faces in the last one. So base times height divided by 2 here. Again, its base is 9 times the height of the base triangle is 7.8, and then divide that by 2. It's 9.8. Oh, no, excuse me. 9 times 7.8, and then divide that by 2, and we get 35.1 yards squared for that. And then we have triangular lateral faces again. Their bases are 9 yards with a height of 10 yards. So it'll be 9 times 10 divided by 2, 90 divided by 2, which is 45 yards squared. Okay? And again, this is a triangular pyramid, and so on a triangular pyramid, how many lateral faces are we going to have? Just 3 this time. So instead of multiplying by 4 for that number, I'm just going to multiply by 3. So the total surface area, or S, is going to be equal to my single base, which is 35.1, plus 3 times my 45 yards squared for my lateral faces. Okay, so in total, 35.1 plus 3 times 45, and we get 170.1 yards squared. Okay, so that's finding surface area of a pyramid. A couple of conclusion questions here now to answer in these notes. So what is the minimum number of sides that a pyramid can have? Well, if we, the minimum number of sides for our base is a triangle, or the smallest polygon we can have is a triangle. And as we just saw in the last example, that triangle had its base, and then it had 3 lateral faces. And so that means our minimum number of sides that a pyramid could have is 4. Number 2, draw a 2-dimensional representation of a pyramid with a rectangular base that has a length and width of 4 and 2 inches and a lateral height of 5 inches. Now, what we're going to see here in a minute, I made a small mistake in making this question because when it comes to having a rectangular base, so let's draw that. Here's our rectangle as a base, and again we're doing the 2-dimensional representation, so it's as if the pyramid was opened up and laid flat. If it has a length of 4 inches and a width of 2 inches, then in order to make the pyramid, we're going to have our triangle lateral faces. Now, we're going to have 4 of them, but the mistake I made was I only gave you one slant height. Or I called it lateral height here, but the slant height when you have a rectangular base, because the distance from center of that rectangle is different for each of the bases of the triangles, the slant heights are going to be slightly different. So let's change this a little bit. And let's do 5, and let's go ahead and we'll throw in 7 inches for the other ones. So these ones that are a little further away are going to have a larger slant height. So we'll call this one 7 inches, and it'd be the same on the other side over here. Let's go ahead and use the 5-inch that I gave you as a measurement for these two triangles and their slant heights. Okay, and then for number 3 then, it says to then find the surface area of the pyramid that we drew for number 2. So again, we have 5 sides total in this. We have our rectangular base. So for the area of that, length times width, 4 times 2, which is going to give us 8 inches squared. Then we have 2 different types of triangles, so we have to make 2 different calculations this time. So we can't just find the area of one triangle and multiply by 4. We're going to have to find each separate triangle. So if I start with, let's say this triangle here, it's got a base of 4 and a height of 5. So 4 times 5 divided by 2, which would be 20 divided by 2, which gives us 10 inches squared. And then we have to find the area of our left and right triangles here. And they have a base of 2 with a height of 7. So it's going to be 2 times 7 divided by 2 for those, or that would be 14 divided by 2, or 7 inches squared. So total surface area then, one base, which is our rectangle, so that was 8, plus we have 2 of each of these triangles, right? So we have 2 pairs of similar triangles, and so 2 times 10 plus 2 times 7 for each of our triangles. Okay, so all in total, 8 plus 20 plus 14. And if we add that all up, let's see, 28, 32, 42 inches squared. Okay, so you're going to see in the assignment that I posted to go along with this surface area of pyramids worksheet, there are going to be some that have rectangular bases on them, so just remember, and they're labeled with the multiple slant heights there, but you'll need to remember that you do need to have 2 different triangle measurements for area there made, and then just remember when you go to add it all up that you have 2 of each of those. Okay, in the summary here, so a pyramid is formed with a polygon base and then triangular lateral faces, okay, that come together at a single point. The number of lateral faces is determined by the number of sides in the either polygon or base would have worked here, right? Either word. To find the surface of a pyramid, the surface area, excuse me, of a pyramid, again, we're going to add together the areas of the base and all of the triangular lateral faces. Okay, so hopefully that gives you an idea of how to complete the worksheet now. You should have enough information to be able to go and answer the questions on the quiz now, which I posted. So feel free to answer those. I'll be getting the quiz form posted soon, and once that form's up there, feel free to start submitting your responses and seeing how you did on that. Again, I'm available through Google Hangouts or Google Meet if you'd like, or by email if you have any questions about any of this stuff that I can answer for you. Okay, have a good day.